Hello, my name is Brenda Wicker, and this is my final project presentation for CIT260, Object-Oriented Programming. For static versus non-static variables, you're going to use a static variable when you want only one copy of a variable that should be shared by all objects of a class. And changing a static variable affects the entire class, not just an instance of it. The static variable is created when the program starts and destroyed when the program stops, so it exists the entire time the program is running. And for an example of it, we want to use a static variable for our current game, because you only ever want one, and if you ever make changes to the current game, you want it to definitely change your current game. So you want it to change any instances of it and not have multiple versions of a current game going on. So that's a good choice for a static variable. For a non-static or instance variable, those refer only to that object instance. When you change a non-static variable, it changes only that instance of it, does not affect the entire class, and it is created when an object is created with the keyword new and destroyed when that object is destroyed. So this example is for the author class. We have the non-static variables name and title, and that's an appropriate choice because, for example, if I want to go change Esther's title, I don't necessarily want to change the other people in the author class. So that's a good choice for a non-static variable. Static versus non-static functions. A static class function or method acts on the class itself and can be accessed directly or by using the class name. And in this example, we're calling the method setCurrentGame. You can see we use the keyword static there to create it, and when we call it, in this instance, we're using the class name City of Erin dot setCurrentGame to call it and passing in the parameter of game. And another static function is always going to be the main function. That's always going to be static. It needs to be able to run without any object being created first for it. Non-static functions can act on a current instance or object of the class and can only be accessed using an object of the class. So for example, here we're trying to use the non-static function getUserInput. And so first we have to create a new string object, which we place inside the inputs variable, and then we can call the getUserInput function with the prompt that we want to give, and we place it inside our inputs in the first position in that array. Array types. Enums are fixed length. They have constant unchanging values. You assign an initial value or object to every position in the array when you create an enum, and all items are the same data type. And the example here is our item type. We only have three. It's animal, tools, or provisions. It's constant, it's unchanging, and there's only the three. And so it's very simple. And you can see an example here in our array. We actually, when we created that, we actually are calling a couple of enums. The item type and the condition are called within that array. So an array is also fixed length. It may be primitive values or objects. All the items are of the same data type. Items in the array may be modified, and elements in the list are referenced by their index position, which you can see. Up here we create a new inventory item array with 5 elements in it, and we place it in the tools variable, so it is an array. And then we fill it, and tools position 0, which is the first position of our element in our array. We create a new inventory item, and we fill it with tools, quantity, condition, and shovels. And you can see we're able to take that shortcut because of our secondary constructor that I'm showing here below. And enum and array, because they're fixed length, they're more efficient because memory is allocated for all memories in the list at creation time. So if that's important and you know you have a fixed length, you want to use either an array or an enum. The third type is an arrayList, and it is more flexible because it can have variable length lists of objects. You can dynamically add or remove objects at runtime. Objects may be of different data types, primitive values must be converted into an object before placement, and elements are addressed by an index. So you definitely want to choose an array list if you need to be able to dynamically add or remove objects at runtime, or you need different data types, or you need a variable length list. Those would be instances when you would choose an array list. A for loop. The for loop, you loop through the array starting at index position 0. You repeat the block of code while I is less, the iteration I is less than the length of the array. And in this instance, tools I, the current spot in the array, is used to get information from that spot in the element. And then you increment I after each repetition through the loop. And the advantage for using the for loop is you don't necessarily have to start at the first position and end at the last position. You could start at the second or third position and end at the fourth or fifth. And so you can use the for loop. You can loop through the entire loop, but you don't have to. It could be a partial going through. The for each loop is a bit simpler in the code. You first will define a variable which will point at the current element in the array, and here we did that. We defined an inventory item tool. And then you have a variable that references the array being iterated through, and up above you see we created a tools array, and so we place that here within the for each. And then the block of code will be repeated for each element of the array with no index. It automatically goes through the whole thing, which avoids the array index out of bounds exception. The disadvantage here, if you only want to go partially through the loop, you can't do that with this. You have to go through the entire array. Custom exception handling. You'll use that to more gracefully handle runtime errors. And so here, our code is going to throw an exception if the function detects a runtime error. In this case, down below, we're testing inputs, our test input function, which will throw a storehouse control exception. It's going to test if the inputs are null or only equal a carriage return. It will throw a new storehouse control exception and sends a special custom message for what that is. And down below, so the exception, if it gets thrown, it's propagated back up the call stack to the method that catches and handles the error. In this instance, it'll be caught here in our try catch with a storehouse control exception, and we're going to handle it by displaying the error view and get that message to print out, and then we'll return false to return them back to the report menu. Byte and character stream classes. A byte stream class is a convenient means of handling input and output of bytes. It reads and writes binary data 1 byte at a time in sequential order, and it's especially helpful for working with files, but it only supports English, not foreign languages. It can be very convenient for simple or sample classes because you don't have to worry about I/O exception handling. For the character stream class, that's designed for handling input and output of characters, and it does support Unicode, so it can be internationalized, and it can be more efficient than byte streams. Writing character data to an external file. First, you need to get the file name to save the report to and test that it isn't null. And so here with our code, we're calling our method to test the input, and if it comes back that it's good, then we're going to take that input and place it into our file name variable, and we'll place that file name variable and pass it to our write report function, which I'll show you in just a minute, which we're going to be creating a tool report, as you can see down below, and write it to file. The user of the game isn't going to actually see any of this happen, so we will send a success message to the console that the report was written to file. We have a success message that we print. Here is our code for write report. The first thing we need to do is go get the tools array, which we do, and place it in the tools variable. And we're going to use try with resources, this first line with try with resources, which has some advantages, including that it's going to close this out automatically when we're done. So it's going to create a new file stream and assign it to a variable. And so we're passing the file name into our new file writer object, which we pass into our new print writer object. which we pass into our report variable. And then within that block of code, we create a tool report using report.println. We create a format string with 10 spaces, 20 spaces, 10 spaces, and we're able to just loop through with a for each loop every element of our tools array and print out the quantity, name, and condition and create our report. And that will get printed because of our print writer. That will get printed to file at the file name that we've given it. At the end, we have we flush out any data left in the file stream. We're going to catch all I/O exceptions, and then it will automatically close the file stream. Let's look at what this game looks like. We've just opened it and started it. We get a welcome message to the City of Erin with description of your responsibilities, and here's our main menu. What would you like to do? Oh, let's go to the help menu. We have options. What would you like to know? Let's see what the goals of the game are. And it says manage your resources wisely and remain ruler for 10 years. So let's return to the main menu. And we have options. Let's start a new game. So every time that you come to the game menu, it's going to show you the current annual report. And so we have that information when we're choosing what to do next. Let's view the map. And here we see our map and explanations of what each thing is, and then it takes us back to the game menu showing us the annual report so we can make good decisions. Let's go manage the crops. And we can choose buy, sell, feed the people, plant crops, etc. Let's pay tithes and offerings. Oh, I'm going to try to cheat the system. I'm going to pay negative 13%. And it doesn't let me do it. I get an error message. That's invalid. It tells me what number it should be between. Fine. We'll pay 100% tithing. Here's our crop management menu. Again, we've paid our tithing and it's been saved. Let's go ahead and go back to the game menu. And let's go to the reports menu and see what we've got. Oh, let's go view the tools in the storehouse. And it tells me the tools of this game are, and it lists them out with numbers and gives a total of how many there are. Let's go print that report. And we're going to call this report Brenda's Tools. And it tells us the tool report has been saved as Brenda's Tools. What would you like to do next? Let's go return to the game menu. Let's save this game. Brenda's game. All right. Now let's return to the main menu. Let's load a saved game so we can see that we can do this. Let's go play Shay. And now it pulls up Shay's game. So all of this is functional and working well. And that is my final presentation. I've learned a lot. I've enjoyed the class and getting to know about programming. And thank you for watching.